So now let me prove the big statement I made. Well, this one basically.
What is that related to? What is that again?
Angular momentum. Yeah, it somehow has to be related to the angular momentum L. So that's the big statement I've made. Okay, so how do I prove this? Let's consider a planet that moves from point A to point B. Point A to point B. Consider this is R. What are the coordinates that I should use when I'm doing problems like this? They're moving in a circle or an ellipse. Polar. Why? Because they are still in 2D, right? So I shouldn't use spherical because that won't make sense, right? Because there's no component coming down. So polar would be a good one. Anyone remember what polar coordinates were?
Like R and 5.
R and 5. So that means if this is my R, that angle should be 5. And can I call this distance S? Remember S equals R theta? Or 5? So does that mean S dot will equal R phi dot? Not quite. Because S dot is not going to equal R phi, but rather it's actually going to equal plus R dot phi, because our R is no longer constant. Actually, can I write ds as R phi dot plus phi R dot as an R vector? Because now I have two components. I have to figure out which one I'm using along the R and which one I'm using along the phi. Now, is this making a triangle or triangular-like thing? Kind of, right? Except it has a little edge, but we'll account for it. Ignore that. The scales we're talking about are so big that our delta S is so small I can almost take it as a line segment. What's an area of a triangle? 1/2 base times height, right? And now we're talking about vectors. So may I replace this by 1/2 R vector times ds? Because this is ds, right? Small segment where it's almost considered a straight line. Now it's not simply a multiplication anymore, right? It's a cross product because we're talking about crosses. Yes?
Why would we just use R and not like the change of R? Because R is like.
It is moving, but I'm only talking about this particular triangle. And I'm considering both R's to be almost constant in this segment only. So if you have an ellipse, is this almost the same as that? That's what I'm considering. I'm only talking about this area. That's why I'm not taking DRs. Yes, you're right. If I was considering this whole area, then you were absolutely right. I have to consider that the R changes. But I'm talking about a segment very, very tiny, where ds can almost be considered to be a straight line, and R is almost constant. Right? Big picture. Not worrying about tiny things. Does that make sense to everybody? Okay. I'm gonna erase that for a second. Sorry, I'm gonna make a small change in here. So instead of R's, may I just call them plus dr and d phi? Don't call them dots. This should be R d phi theta hat plus R phi R hat. Are we all good with this? Yeah. Do we all understand how that happened?
Yeah.
It's because R is also not a constant, R is a variable, and phi is a variable. So you have to differentiate them twice. Okay, so we're good with that. That means I can write this area as 1/2. What's the base? R vector cross ds vector, right? These are both vectors. Agreed?
Yeah.
And this should be magnitude of those. Now may I plug this value in here?
Yeah.
So this means I will have 1/2 r times r d phi hat plus dr phi r hat. And both of these have to be the magnitudes. So this means I can rewrite this as r hat times r d phi hat plus dr phi r hat. Now I'm going to multiply them through. What will I get? Fix if I go wrong somewhere. R squared d phi r hat cross phi hat plus this plus r dr phi r hat cross r hat. So far so good? What is r times phi? Good. Do the smiley face again. R phi theta. So what is r cross phi? Theta. I can rewrite this as 1/2 r squared d phi theta plus, what is r cross r? 0. Plus 0, right? And what am I left with? 1/2 r squared d phi for a magnitude. What is magnitude of theta? 1. So I can get rid of the magnitudes. Am I only left with magnitudes now? Okay, so that means I will have dA equals this. Good? Okay, may I differentiate both sides with t? What will I get? Differentiate with respect to t. What will I get? dA over dt equals r squared 1/2 d phi over dt. Because r is being considered as a constant for r triangle only. This means I can rewrite this as a dot equals r squared over 2 phi dot. And if I consider my angular momentum situation, what is L? R cross P, which can also be written as R times mv. In this case, will V be S dot? When R is a constant, can I write this as R m R phi dot? So I'm only considering this tiny segment. Is this R the same as that R?
Yeah.
Can I write this S dot as R phi dot? Yeah. So may I write this as R squared m phi dot? Then may I write this as L over m? So far so good? May I plug this value in here?
If you feel like it.
I do. I really, really do. And I made a claim at the beginning. That claim said what?
We made a claim saying that it does not depend on how we structure that varies with radial
But
distance.
before that, the one we put in the golden line.
Areal velocity must be somehow related to
What does this equation say?
Angular areal velocity equals angular momentum. That's kind of cool. We just thought you were crazy.
I,
I still think he's crazy.
well, thank you.
You're welcome.
Okay.
In a good way.
Okay.
You
I will take that. Now, if angular momentum, we said angular momentum was a constant here, right?
Yes.
Yes? So what does that tell you about areal velocity? If L is a constant, that implies by default that areal velocity must also be a constant. Woohoo!
That's actually kind of fun. This is the most fun I've had in physics all year.
Woohoo!
Good question.
Yes.
Why are we able to cross out?
Okay, that's a good question. So why are we able to take this cross out? Is that the question, right? Okay, so let's say we don't take this cross out. What will we get? R hat times M R phi dot phi hat. Agreed?
Yes.
Okay, then I can do R squared M phi dot R hat minus that, which is just theta hat. Why isn't it writing? Which is just theta hat, and the magnitude of theta hat is 1.